Hi everyone, welcome to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we're going to be having a presentation for our course ROS Basics in 5 days in C++. And our presenter is Talha, so he's going to show us how he completed his project using a Turtlebot 3 in a real robot environment. So without further ado, hi Talha, how are you?
Fine, thank you. How are you, Mr. Rodrigo?
I am good, thank you very much. I'm excited to see your project. So whenever you want, you can start sharing your screen so we can get started with it and just explain your project.
Right. Uh, Let me share my screen first. Uh, is it visible?
Yes, we can see it. We can see it.
Right. Now here I'm going to launch my launch file, which includes the three nodes.
Yeah, and while it's doing its thing, you can kind of explain what
Right.
it's doing.
Now it will first call the service and it will see that which one is the smallest value, which of the smallest is the value amongst the array of the lidar, and it says that smallest is 0.193 and the index is 202. Now it will rotate and it will try to bring the front lidar array to around this value.
Okay, so now,
So the service is running right now.
so right now it's looking for that smallest value.
Yes.
So I'm assuming it's gonna do a whole turn.
Yes.
Yeah.
Yes, it will do the whole turn.
So again, this is the service that finds the wall.
Yes. And then it has found the front value and then it stopped and moved backward,
Oh yeah, move
so
backwards a little bit.
that its value is around zero point 0.3 meters from the wall. Now it
Oh,
has reoriented itself and now the service has completed, and the goal action goal just went active, and now it is recording the odom values, and it is giving the feedback.
so
Now
you're
here is the
echoing.
feedback. Yes. Now the current total distance it has traveled is around this.
Oh, nice. So that current total is what it's moving forward, or what is it?
The distance it has traveled.
Okay, okay. Looks like a
Uh,
really smooth movement. Nice.
right, thank you. And the result topic would be echoed just once after has completed one lap.
Okay, so we're almost done there to one lap, right? Yeah.
Yes. Now here it has stopped. It is the first lap, and the result has been echoed. And here is the list of odom values
Mm-hmm.
which it has recorded as a result. I had displayed it at the end.
Great. So to sum up, then it's divided in three parts. One is the service that finds the wall, then the main node that follows the wall, and then the third, it's an action server that records the odometry while it's moving.
Yes.
Great. So it looks like it did what the project asked for. So if you don't mind, yeah, like go ahead and show us a little bit of your structure so we understand how you did these nodes.
Right. Now, this is the main node which is calling the client's service client and the action clients, and it is the main node which is responsible for the um, wall following as well. Now, let's go through the points one by one.
Mm-hmm.
Uh, Here we have the points. Now, what we had to do was that the project consists of three sections. It is the number one section consists about practice about topic publishers and subscribers. Here we are subscribing the laser topic, and we are publishing the velocity values, linear.x and angular.z, uh, for the differential drive. And here is the structure for the movement of the robot. Now, the first thing which we had to do was that if the rate distance is bigger than zero point 0.3, the right rate distance is bigger than zero point 0.3, then you need to make the robot approach the wall a little by adding some rotational speed to the robot. Here, what I've done is that if it goes away from the wall greater than zero point 0.3, then I have further divided it into the two sections that it would take a strict action. It would take a strict action while um, it would take a strict rotation,
Mm-hmm.
and uh, first it would rotate with the rotational velocity of zero point 0.1, and then it would rotate with the rotational velocity of minus zero point 0.4. And then afterwards, what it would do is that if it is smaller than zero point 0.2, then what it would do is that I have further divided it into the four categories,
Mm-hmm.
three categories. If it is closer, if it is less than zero point 0.2 and greater than zero point 0.5, then it would move anti-clockwise or in the left direction with zero point 0.1, and it would have some linear velocity as well, so that it can move in a curvature. And here this condition, if it is less than 0.15 and front is greater than zero point 0.5, then it would take more the I have increased the angular velocity about z axis over here. And then if in the third condition here, if it moves very close to the wall, then the right array, the value of right array of lidar would go to infinity. So
Mm.
here I have compensated that if the right array lidar value is greater than 20, then the z angular dot z would go to zero point 0.4, and it would keep moving forward, but it would take more angular velocity over here.
Right, because
This
you're too
condition.
close to the wall in that case, right?
Yes, yes. And if it is in between zero point 0.2 and zero point 0.3, the value of right lidar is, then it must keep moving forward without rotating clockwise or anti-clockwise.
Hmm.
And then if the front is less than zero point 0.5, here it was written that if the front array is shorter than zero point 0.5, then the robot must turn fast left, so that it must not it must shift to the next wall. So here it is moving linear as well and rotating anti-clockwise, and so that it may, if the wall is approaching, then it may shift to the next wall by rotating left. So this was the first section, and we had to then make a launch file in which uh, the node should be running. And here, since this is the final form, therefore all three nodes are included over here.
Mm-hmm.
Now let's go to the service. Now here it is calling the function do underscore stuff, and here it is calling the call service function. It is a client which calls this service srv underscore t, which has been described over here. Here. So now this SRV consists of uh, two the response and request, and here is the response. The request doesn't have any variable, so we can call it without any value of the request, and once it is done, then it will give the wall found will be true. And now here is the function. Once the here is the service wall node. Once the service has been called, then service a callback function would be triggered. Um, and first I have made the response as false, and I have kept the value of the smallest array. Smallest is the variable which will keep comparing to the value of the arrays of the lidar. So it will keep comparing with the smallest one, and the smallest would be the smallest achieved value would be displayed over here, and its index would be displayed over here in ROS underscore info. Here I have kept now this is a while loop in which the front must be greater than smallest plus 0.07. Here I have kept a margin over here because I am assuming that if the robot doesn't rotates about its axis, so there can be a uh, a difference in distance. Therefore, if while the value of front is greater than the smallest plus 0.07, then it must keep rotating anti-clockwise. And once it has the front value has been is less than smallest plus 0.07, then it would exit this loop, and it would keep spinning with this frequency, so that it can update the laser values as well. Then it would stop, and then it would find that if the distance of its front array of the lidar is greater than 0.3, then it must approach closer to the wall, otherwise it must move away from the wall. Here is minus 0.04.
And that's what we saw earlier, right? That it moved back.
Yes.
Okay.
Then it stopped over here, and then we have to now we know that the front is around 0.3, the distance from the wall. Now it will keep rotating anti-clockwise until the right distance is greater than 0.28. Here I have again kept a margin over here. I could have written 0.3 or something like that, but I have kept a margin over here. And now it will stop, and then the response is that the wall has been found and it is true right now.
And that's the service.
Yes, that's the second part of the service. Now here comes the third part of action. Now here is the action file in which there is a point type list of odoms, which is the result, and we don't have any goal over here, and the result is this one, and the feedback must be current underscore total,
which is what you showed us when it was running, right?
Yes. And now here is the action server class or action server node, in which action server class is over here, and the frequency was supposed to be 1 hertz,
Once, yeah.
or it must keep recording after each second. So when it is called, then when the action the server is called by the client over here, and this do underscore stuff, it sends the goal. And here three functions are over here. Done underscore cb, it is executed when the action server has been completed. And active, it when it goes active, the action server goes active, and the feedback is continuously running over here. So here is the client of the action server. And now
So
uh,
that, I'm sorry, so that action client starts recording after the service, right? Because you're
yes,
calling. Yeah. Okay. I see. I see. So
yes,
it's only the lap distance.
yes, it is only the lap distance. Now, what I've done is that this, while it is it is the callback function of the action server, and here I've stored the initial values of x-axis and y underscore axis. And then here the initial values of x-axis and y-axis are recorded, and which are the current values, and x current and y current are also stored over here. Now the initial and x current values would initially be same, therefore the distance traveled would be 0. So here I have you know uh, recorded that while the distance is less than 7, it is greater than the distance of 1 lap, right? So if the preempt is requested, or if it is requested that action service must be cancelled or preempted, then the ROS error would be displayed over here that preempt has been requested, and the action server would be set aborted,
Mm.
and the success would be false, and it would break from this while loop. Now here is the distance calculation, and the formula is very easy, that x current minus x initial square, and current y current minus y initial square, and under root square root of this would give us the distance. And after calculating the distance, now the initial values would be equal to the x current values, which were the previous values of x current and y current. And then the x current and y current values would be the newly updated values of this after going through the callback of
Yeah. Yeah.
odom.
Of where the
uh,
robot is in that moment. Yeah.
yes. Now the current total feedback dot current total, it is the variable of the feedback, and the value of it would be equal to the distance, total distance, which we have calculated over here. And then the odom underscore sto, here I would be storing the values of odom sto dot x, odom sto dot y as x-axis and y-axis and z-axis. And then odom underscore array is an array in which the odom underscore store, the stored values would be placed, and it would be pushed back. It would keep pushing
Mm-hmm.
these values back, and storing new values of this odom underscore sto. Now here I have done this, that if the distance is greater than 3, um, it means that it has traveled a distance of 3 meters, and the x start is less than x current. uh, um, the x current is the current value of x plus zero point 0.3, if so that uh, it is and it is the current value is in between the x start plus minus zero point 0.3.
I see. So it detects the lap.
Yes, it detects the lap, and it will break from over here, and it will keep spinning so that it can update the autumn values. Now, after breaking the loop, if the success is true uh, and preemption has not been called, then what it would do is that it would store the value of this odom underscore array and the result list of odoms, and it would display the array value like this. And rest is the odom callback function and the laser callback function, so that it may keep updating the values. So this was it, and I hope I'm clear.
Yes, nice. Could you? So where do you send the command to stop the robot when the lap is completed? I didn't see it in the
Ah,
action.
yes. Uh, Over here, let me show you. Now, what I have done is that I have, uh, here, if the done underscore action server is false initially,
Mm,
I have, called this, initialize this variable
mm-hmm.
as a Boolean. And now here the goal is done. Here it is updating its value. If the state underscore result is done, and so if it is done, then it would become true,
Mm.
action underscore server. And now if the done underscore action server is equal to true, then it would, stop the report, and the ROS, this node would shut down.
Oh, I see. Nice. So it's very clean and it finishes and the node ends.
Yes.
Nice. Well, that's very, very well explained. Do you mind stop sharing your screen so we can?
Yeah, sure.
All right. So, congratulations, Talha. That's really, really nice and clean, and it does what it's supposed to. So, congratulations. That was
Thank
a
you.
very good job. Some things I liked is that you added a little bit of conditions. For example, when that service um, goes forward to look for the wall, and then if it's closer than I think it was like 30 centimeters, it goes back. So you start the wall following at at a set distance. I thought that was really nice, and I also liked how you did the three notes separately. And that's why I asked about when does it stop. That was nice that the action server needs to return that okay, I'm completed. So you send the stop published velocity to the robot. That was really nice. Now, let me ask you. So, how did you find the what were some of the obstacles when you were trying this in a simulation versus the real environment? Was there anything that needed you to pay special attention or something like that?
Yes, actually, I was facing difficulty while multi-threading. In simulation, I was using multi-threading uh, while spinning, so that uh, it doesn't blocks, the uh, calling function.
Yeah, yeah,
Uh, the callback function, but it wasn't working in the real robot lab. But due to the guidance provided by you, I used the spin once function, and it gave me a major control because I could spin it at a certain frequency and spin it once only, so that it doesn't blocks the callback function. So the previously the continuous spinning was blocking the callback function, but the spin ones gave me more control over it, and um, I could use it. Um, I could spin it according to my preferred, frequency, and so that it doesn't blocks the callback function and other the procedural the procedure that is going on in the callback function.
yeah. Because that blocking issue will happen when, and it will translate into the robot kind of moving forward, and then because that callback function for the scan is blocked, then you just run into the wall. So that's nice that you do that spin once, so you have more control. And another question that I have is, so technically, what happens if the action returns not succeeded? You know what I'm saying? So what would happen in the event that either the service returns the false or the action server returns the false?
Uh-huh.
It
I
will get
must have, yes, I should have placed a condition. I think if the action server goes, if it doesn't succeed, then it must, shut down the uh, node of action server, as well as the uh, initial node of the topics subscriber and publisher as well. I
hmm
think I should have uh, placed that condition as well.
Well, yeah, there's a ton of things you can just keep adding and adding. That's why I said that I liked that you kept having conditions that you added that were not necessary. For example, well, maybe they were for your application, but what I saw that I also thought was nice is how you dealt with the robot being very close, is because you get thrown an infinite value for the scan. So you had a condition for that. So yeah, because I was thinking, so what if the robot is just not detecting? So what if it just goes somewhere else? And because you had a condition, I think, for being like 30 centimeters away from the starting position, then that would trigger that, okay, my action server is done, then the wall following node is done. But yeah, you can just keep adding conditions like that. So I was just wondering. And the last question, I guess, is with the service as well. So I saw that you call the service in the beginning, and if the service fails, you just the robot will stop, and it won't start the wall following, right? It's like a safety,
Yes.
inherent safety mechanism. So I thought that was, really well structured.
Yes, I use classes as well.
Yeah, I saw it was really, really, really nice. And but yeah, I mean, congratulations. You
Thank
did
you.
everything precisely how it was asked. So congratulations. It was a nice project, and good job.
Thank you.
Uh-huh. And for everyone else that's watching, I mean, you can do what Talha is doing here to practice his ROS skills. And I hope you guys, if anyone's watching, you want to come check it out and take our courses and attempt to do our projects here, which is a lot of fun, and you get to learn a lot, including presenting your knowledge to everyone. So thank you, Talha, and thank you everyone for
Thank
watching.
you.
And
Thank you, Mr. Rodrigo, for the
our
guidance as well, and for providing a great platform to learn ROS. And um, I'm really grateful. Thank you.
oh, thank you. That's what we're here for, and keep pushing your learning, and we hope to see you again here soon.
Sure.
All right, guys. That's it for us, you guys. So we'll see you next time for our next presentation here at Becoming a ROS Developer channel. Thank you, guys. Bye.
Right. Thank you. Bye.
All right, Talha, that is done.